Okay, let's see. First thought, we need to get an idea of if we think this series is going to converge or if it's going to diverge. And we're thinking, what is it similar to? Now, when I look at the series where the terms are 1 over 2 plus the square root of n, I'm thinking that looks pretty close to just 1 over square root of n, right? So now let's see what we can do with our terms. So we've got 1 over 2 plus square root of n. Which one is bigger, this or 1 over square root of n? Well, since the denominator is larger, the reciprocal is going to be smaller. So we can say, aha, we know that 1 over 2 plus square root of n is going to be less than or equal to 1 over square root of n. This is going to be true for all n. And 1 over 2 plus the square root of n is going to be bigger than or equal to 0. So here we go. Now, let's see here. Let's look at the behavior of this series, of the larger series. This is, does it converge or diverge? It's going to diverge because it is a p-series. And it's a p-series with p equal to 1/2. So just kind of as a sidebar, we can rewrite this as 1 over n to the 1/2, right? So p is 1/2. Since p is less than 1, this series diverges. We're in a situation where this was a poor choice because the direct comparison theorem the direct comparison test won't help us in this situation, right? Because remember, for a direct comparison test, you need to say that your series is kind of squeezed in between something that is convergent, right? So we're in a situation where we've got a divergent series. So if we were to draw a picture of the scenario, it's kind of like, you know that you've got some series that is, super big, doesn't converge, the area doesn't converge. And we've got a series that we're comparing it with, which is beneath it. And we don't know if our series has terms that go like that, in which case we would think, convergent. Or if our series has terms like that, in which case divergent, right? So we've just got to pick. We've got to try something else. Okay, so the next choice might be to say, well, what about the sum 1 over n? Right, let's look at that. This isn't going to be true because if we look at our terms, is 1 over 2 plus the square root of n less than or equal to 1 over n? Well, let's cross multiply. We'll get, is n less than or equal to 2 plus square root of n? No, because n is going to grow way faster. N grows faster than the square root of n. Right? So maybe we should actually switch it around. So if we have, this is less than or equal to 1 over n, right? This might make a little bit more sense. True. So 1 over n is always going to be the square root of n. For large n, it's going to be bigger than or equal to 1 over n. This is true for large n. So we'll say for large values of n. Okay, so now, as a result, 0 is less than or equal to the series where the terms are 1 over n, and that's less than or equal to the series 1 over 2 plus square root of n. Now, Do you recognize this series? This series is the harmonic series. So, since it's larger, and that's it.